previous video we looked at node 1. Now on my layout this is going to control turnouts and signals. To be able to use the servos to move the turnouts to the known positions of closed and thrown, I need to use a calibration sketch. I created this sketch to work with the positions that I want. I will make this sketch available on the github page and link it into the descriptions of the video. I first use the library servo.h, so I need to include it. I then need to create the object for servo 1, so that's how I do that here. I then need to create two variables. The first one is string, read string. This variable will hold the bytes from the serial monitor when I type them in. The next variable is int pos equals 90. This sets the servo to the mid position. This is important when we first set them up, to have them in the middle so that in a known position. We then go into the void setup. The first thing we need to do is tell the Arduino which pin we're going to use for the servo. In this case, servo.attach4 means the servo is on pin 4. The next line of code is servo1.write position, so that will send the servo on startup to 90 degrees. I then start the serial.begin at baud rate 9600. This we use for typing into the serial monitor the positions we want the servo to go to, and it will also feed back that the servo is at that position. The next part of the code is basically stuff that will get written to the serial monitor when you start it up, and this is basically serial.print new line warning exceeding the maximum range could damage the servo, through a load of different bits of text to warn you about using this code. The next part of the sketch we move into the void loop. In the void loop we have while serial.available, and we create a variable char c, and that equals serial.read. We then read string plus equals c for the variable, and we delay for 2 seconds. The delay 2 is important to allow it to loop through, to allow you to add more than one figure. So if you wanted to use 110, you need to be allowed to type in 3 figures. Now we also are going to use a couple of other characters. These characters will be x, plus or minus. We then come to the if statements, and in the brackets we've got read.length function greater than 0. This means if we've typed something in the serial monitor, it can then do something. If we don't type anything, it'll just sit there, won't do anything. The next if statement, which is read string.indexOf, followed by brackets x greater than 0. This basically means whatever we type, so if we type in 90 followed by an x, we want it to move the position equals read string dot to int. So it converts the string into an int value that we can use later. This gets used later when we want to move the servo to a known position. So if we wanted to go from 90 to 110, we would write 110x and the servo will move to that. The next if statement is slightly different. This if statement and the next one work slightly different in the code. It still reads the string, and if it's got the plus sign after it and it's greater than 0, the position equals position plus the read string to int. So if the servo is at, say, 80 and you write 1 plus, the servo will move to 81 degrees. Or in the next if statement, if you wrote 1 minus and pressed enter, it would reduce the position by 1 degree. The last bit of the code is here, which is serial.println, which is print a new line, the position. This is the position you have typed into the serial monitor, be it an X on the end of it, a plus or a minus. And then we have serial1.write position. So whatever that value of the position is, it's going to send it to the servo and move it to that position. And then we have read string equals. This will enter the input for the next position to be typed in. So with the code uploaded to the Arduino Nano, if we click on the serial monitor up here, this will start this screen up, and then we should start to see the text coming through explaining how to use the program. Here you can see the servo is now in 90 degrees position. If we type in here 180x and press enter, the servo now moves to the 180 position. And if we now type in 0x, it will move to the 0 degree position. I could type in 10 plus and enter, and now the servo will move to 10 degrees. Hopefully that explains how you can use this sketch to calibrate your servo to your turnout.